Hi, I'm Justin Hansen, and today I'll be going over Robotics Midterm 2, which the goal of this was to solve a maze, solve it from either the red to the green or green to red. And I'm showing a video of a somewhat simple maze because it helps demonstrate something later on. Uh, but what this is going to do, I'm going to have this robot take an image of the maze, have a YOLO model analyze it and recognize different objects that are in the maze. Like it'll see the maze walls and it will see the circles, and it'll pass the walls and the circles into an A star algorithm, which will find the shortest path through the maze. As we'll see later, I also add buffers that kind of introduce zigzags into the solved path. However, it helps it keep it away from the walls, the end effector, because the robot will go down and trace the solved path along the maze. And another part of this project was to incorporate an LLM in some way. The way I have it work is I take the kind of zigzagged path from the solving algorithm and I use a llama model to um, reduce the number of nodes in order to make it more straight. And so what you'll see is it'll take a picture, it'll analyze the best image, pass it into the A star algorithm while reducing a buffer size to kind of try and keep it closer to like closer in the center of the maze boundary. And then it'll pass the nodes from the solution algorithm into the llama model, which will then interpret it, reduce the total number of nodes, and once we have the shortest um, path possible, the robot will go down and trace the final path. And so we'll see that in just a second. And so here I'm going to look at, I'm going to take a capture of the image, or take an image of the maze, and you can see these were the best images it took, and now it's asking me for an input, so I'll tell it where to start. I want it to start at the red circle, and here it's passing the solved, or it's trying to solve the maze, and it found it really quickly, and then it passes that into the LLM. The LLM found, I think, about four um, places to reduce the number of nodes, and then that was the solution. Once it found the shortest number of nodes, it passed it through, and you can see the LLM reduced it from, I think, 16 to 11 uh 11 nodes. And right here you can see the light blue is what it was, the dark blue is what the LLM reduced it to be. And so it was going to zigzag much more along those straight paths, and instead it only zigzags about two times at the very end, which is a really strong reduction, um, in my opinion. It makes it a lot more straight than previously. And so, one more thing that I want to touch on is why my maze looks the way it does, because it does look odd. Um, and so, what you're seeing is a regular maze, but then with some added shapes mixed in to kind of introduce hallucinations that I want to make sure that my model that is interpreting the mazes doesn't get confused by random glare or um, random like miscolorations in either the paper that it's looking at or the ground that the maze is on top of if it's not on paper. And so this just helps ensure that my model is accurate in like a wide range of situations. And overall, my model works as I wanted it to, and follows the path in a fairly smooth manner, gets reduced pretty well, and has been trained to see a lot of different variations in wall thicknesses, circle color, circle sizes, and overall maze size and complexity. So um, that's about it for the midterm. Thank you.